All right, so we just learned about 1,2 alkyl shifts. What about this? What's going to go on here? So essentially, this is a good time for you guys to kind of experiment with this idea of shifting to make a more stable carbocation by trying to predict the product. So I would advise you now to pause the video and take a minute, work through the mechanism, and see what you would predict as the major product or products. There could be multiple major products here, and then restart the video at that point. All right, you did that. Nice job trying. Probably did a really good job. So what's going to happen? Here, we still have our alcohol. We have sulfuric acid. We're going to transfer a proton to our alcohol. That makes our OH2 plus leaving group. Well, what happens when we have good secondary leaving groups? This is a secondary leaving group. It depends, right? Do we have a strong nucleophile, strong base? No, we don't. In that case, it's going to form a secondary carbocation. So that provides this intermediate here. And what do we have there? We have a secondary carbocation. So anytime we see carbocations now, we have to ask the question, do we have the ability to make a more stable carbocation? Well, what's more stable than secondary, tertiary? Well, there is a position right next to it that's tertiary. So how could that positive charge be moved to that location? Well, again, remember, it's not the positive charge that's moving, it's something else that moves, and then the positive charge moves as a result. So again, if you haven't done it yet, this is a good time to try and pause the video, see what can we move to get the positive charge to that tertiary position. All right, you did that. Great job. So we have a hydrogen there that can pick up its electrons and move to the next carbon. Once it does that, we have the hydrogens here, and there already was a hydrogen there, right? This carbon had a carbon, and a hydrogen. Now that that hydrogen moves there, there are two hydrogens there, and we have the positive charge right there. So what are going to be the major products that form from this species? Well, these would be beta hydrogens to the carbocation. Where are the other beta hydrogens? We have some here, some here. So essentially, we will have multiple options for the elimination to occur. So I'll do two different colors here. If the sulfuric acid conjugate base were to grab that proton, and then this carbon-hydrogen bond breaks, making a new bond there, we would form that alkene. If instead that anion grabbed that hydrogen, the electrons would move there. That would produce this structure. So which of these is going to be the favored product? Well, we have a tri-substituted alkene versus a tri-substituted alkene. Both of them are pretty similar in stability then, right? So we're going to get a pretty messy mixture here where we would have that and that in roughly equal amounts. One other thing to think about, I'm sure people are asking the question, well, why didn't you take this hydrogen here? Because that hydrogen and that hydrogen are identical. If we have the double bond here versus the double bond there, it's the same product. So hopefully you already got there, but now you were told. So that's good. So alkyl groups can rearrange. We could have a CH3 or even a carbon chain move from one location to another. But also, hydrogens can rearrange. They can pick up their electrons and move to the next carbon. Why did it do that? It did it because we had a secondary carbocation changing to a tertiary carbocation. Anytime that can happen, it's going to happen. So we have to be aware of that and look for those possibilities. Again, course packet, what would we call that one? We'd call that a 1,2 hydride shift, movement of a hydrogen atom from one carbon to an adjacent atom. it resulted in a carbocation rearrangement. Yeah.